Welcome to this next video of our Grade 10 and 11 Trig Theory revision, where we will cover trig graphs. Just a reminder again to continue taking notes. Hopefully your theory notes are building up nicely to support your journey with trig. Once one looks in depth at the understanding of trig graphs, I find things definitely start coming together really nicely. In this video, we will start by looking at the axis angle values for each ratio, and then we will look at seeing how it flows into the graphs and how it all comes together. So, starting with the graph of sine, I'd like you to begin by completing the coordinates on the axis points of this unit circle. I've done the first one for you, as you can see, and will refer to this unit circle throughout the video. Pause here to give yourself a moment to do this. Okay, great. Let's double check first that you have the correct coordinates in place. On the x-axis, y is 0, and x, 1 and minus 1. And then on the y-axis, x is 0, and y, 1 and minus 1. And now, using the relevant coordinates of these points, go ahead and find the values of all these sine ratios, working with the definition language of x, y, and r. Remember, sine is y over r. Also, just a reminder that r is positive, and in this case, because of it being a unit circle, r's value is 1. Pause the video here while you fill all of these in. So here are all the values. Hopefully yours are the same. Note the y over r relationship in each case. Our next step now is to set up a system of axes to plot all these points and then draw in the graph. Pause again here to give yourself time to do this. And here is your sine graph. Does yours look similar? Note y is 0 on the x-axis, and so sine is 0 at 0 degrees, 180 degrees, and 360 degrees, and the same towards the negative. Also, you can see clearly here that the value of the standard sine graph will always lie between and including 1 and minus 1. Let's follow the same procedure now for the cos graph. So, using the same unit circle, complete the ratios here. Remember, cos is x over r. Pause the video to give yourself a chance to complete these ratios. As before, note the relationship in each case. For cos, it is the ratio x over r. Maybe take a moment to check through to see that all your ratios are the same as here. Then the next step here, again, is to set up a system of axes to plot these points and then to draw in the graph. Pause to give yourself a moment to do so. Here is your cos graph. Check that your graph has been plotted correctly, noting again that x is 0 on the y-axis, therefore cos is 0 at 90 and 270, as well as minus 90 and minus 270. And also, just like sine, the visual of this graph makes it clear that the value of cos lies between and including minus 1 and 1. It may be useful to pause on the range of sine and cos for a moment to understand it more deeply. So the hypotenuse, which is the longest side of a 90-degree triangle, is in the denominator for both the sine and the cos ratios. So r, or the hypotenuse, will therefore always be greater than or equal to x or y. And what this means is that the sine or cos ratio of an angle will therefore always be either a proper fraction, or when r is equal to x or y, which will occur at an axis angle, the ratio value will be 1 or minus 1, depending on the sign of x or y. And this is why all sine and cos ratio values lie between and including 1 and minus 1. Let's now follow a similar process for tan. Remember, tan is y over x. Pause the video to fill in these ratio values. You may have realized that with tan you need to consider the tan of other angle values as well, as the tan ratio of these angle values doesn't give you enough information to sketch the graph. Let's choose the angle of 45 degrees and consider the tan ratios of its family. This gives us points along the unit circle where x and y are equal in value. You will just need to be mindful of the signs of x and y in each quad. Pause now again to give yourself a chance to complete these tan ratio values and then go ahead and plot them on a system of axes. And here is the graph of tan. Because the axes values that we worked out initially only gave us that the graph was 0 on the x-axis values and that it didn't even exist on the y-axis values, we saw that we needed to know more about what happened in between. The 45-degree family of angles gives us a start to see what happens between these points, but exploring more ratio values along the way and seeing their trend would definitely help to understand more about the shape of the tan graph. You will also notice clearly as you check your graph that there are big differences between the tan graph and the graphs of sine and cos. In the case of tan, there is no limit to the range of the graph compared to sine and cos that lie between -1 and 1. And for tan, its domain is interrupted where it is undefined, which, if you remember, occurred at 90 and 270 degrees when the x-coordinate of the points from the unit circle was 0. The same is true, therefore, also for -90 and -270 degrees. I've included the unit circle again here so that you can double-check your ratios without having to go back. So, for example, if we look at the coordinates of 90 degrees, y over x is 1 over 0, which is undefined because the denominator is 0. Therefore, the graph is undefined at 90 degrees, hence the asymptote. And just a quick reminder here that an asymptote is a line that a graph tends towards but never touches or cuts. You may want to pause the video here for a moment to give yourself enough time to go thoroughly through everything about tan. Here we've given you all three graphs to view together. Pause a moment to consider what they have in common and where they differ. Knowing how to draw your graphs with confidence can make such a difference to your approach to many types of trig questions. For example, when the ratio of an axis angle appears in a reduction question, like sine of 0 degrees or cos of 90 degrees or tan of 180 degrees, etc. If you know each graph confidently, then rather than reaching for your calculator, you can quickly make a rough sketch of the relevant graph and simply read off the ratio value you need. So we really encourage you to get comfortable with your trig graphs by practicing drawing them over and over. Let's look now at how it all comes together. I know this is a full slide, so I think let me orientate you first, and then we can look at a couple of things that are useful to compare across the three ratios. So first, the sine, cos, and tan ratios are each covered separately over the horizontals. And then if we look down vertically, the first aspect to compare is the three special angle families and their triangles, which you may remember we mentioned in an earlier video. And the focus in the next column is on the graphs. Let's start by looking at this first column where we consider these unit circles. Each family is applicable to all three ratios, of course, but to orientate you around ratio values, we chose to place the 30-degree family on the sine wheel, the 60-degree family on the cos wheel, and the 45-degree family on the tan wheel. You may have noticed that we've shaded the quads where the ratios are positive, and so for sine, we've shaded where y is positive. For cos, we've shaded where x is positive, and for tan, we've shaded where x and y have the same sign. This column also holds the unit circle outcomes. It is worth noting that both sine and tan of 0 degrees is 0. In other words, both these graphs start at the origin, where for cos of 0 degrees is 1. Let's have a look now to how all of this unfolds onto the graphs alongside in this next column. This perspective gives us quite a different view of the four quad angles. If we have a look at these first, the first quad angle is just this acute angle. The second quad angle is 180 minus the acute angle. Then the third quad angle is 180 plus the acute angle. And lastly, the fourth quad angle is 360 minus the acute angle. Seeing it in this view really confirms beautifully that the ratio values at these positions are very definitely the same, the only difference being their sign. Again, here we have shaded in where each ratio is positive, and you can see clearly that they are all positive in the first quad, and so sine is positive therefore in the first and second, tan is positive in the first and third, and cos is positive in the first and fourth. Hopefully this slide is a little less scary now that you know what's what. We encourage you to pause the video for a good while here to really get a good grasp of everything. It is when trig starts coming together that things start making more sense, and it all starts to feel so much more manageable. And I hope you are starting to feel this.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.